recording that. Let's do an update on where we are with a heavy-duty mill. If we go to the 2-inch universal axis page on the wiki, well, look at this. Look at all these library parts that are already seated in there. That's awesome. And then the overall file, I believe, is
It's on that page. Right there. Very first gallery.
very first. So look at this. Let's actually load this up, boot this up here, because that's pretty nice. Opening that up. Aiden, briefly, how do you download? So is that what we are looking at? Or does it have more?
There's more, that's just one component. I think you can
Where
click
is it?
on the whole
Looks like
thing,
you've hidden some.
the assembly, just click on the assembly or something.
Hang on. Let me take over for a second.
That's funny. I saw the whole thing before. Maybe I don't. Oh, that's a file. Maybe I downloaded earlier.
Yeah, so this is,
Go back.
can I just hide this?
Yeah.
Okay, so this is just one axis,
Yeah.
right? So, first thing to do is go to FreeCAD, Tools, Add-on Manager, Workbenches, A2
It's
plus.
right there at the top. Yeah.
Where?
It was the second one.
A2 plus. Install that.
Uh huh.
This is essential because this is how I made this. And then, while that's installing, if you go to the 2-inch axis page, you're going to get a link to this Dropbox folder. And this is just because I don't have GitHub and this file is larger than 1 megabyte. So you click the Dropbox link and there's a compressed zip folder. My recommendation, it shows up as a folder. My recommendation is just, but it's a compressed zip folder, so just direct download, top right.
Yeah.
So then we've already got that on our desktop. And
But
here we've extracted
I
it.
don't think it's that.
No, this is,
Okay.
delete, this is just, delete.
Anyway,
Anyway,
trash.
So this folder contains all of the assemblies, sub-assemblies, and individual parts. So anytime I made an assembly, I wrote assembly at the end of the file name. So this 2-inch universal axis half component assembly, that's actually our y-axis. And I know my naming scheme is really bad. Let me view as a list. There we go. So, if you organize this folder by date modified, the very top one is the mill assembly, and that's going to be everything. This is the y-axis,
Yeah, open it up.
z-axis, and then this is the x-axis right here. And if you open up the mill assembly file, it'll take a moment to load.
Is there a way within the new assembly to load it with substitute parts that are simplifications? Because we can, for example, take one of your files and get rid of the teeth, for example, which might take a lot of memory or things like that.
So yeah, what you would do is you would want to. Okay, so let me show you the workflow on this. If you want to edit a sub-assembly,
Can you view and perspective view?
sure. But I mean,
It looks kick-ass.
This has got to add on. Because the best thing for me to do is to show you how to actually edit these, and you have to use this toolbar.
Mm-hmm.
So, you know, I don't.
So it's still installing the bench,
I guess so.
downloading.
I don't know. It's slow.
Yeah, for which reasons the typical thing that we do when we upload files to the wiki, we have the full file and then we strip everything we can while still making it look the same, or just draw a very basic shape from scratch and resave that.
That's fine. Anybody
So
can
that-
do that with these. But I would do it. I would go into each Like, what do you do? Create simple? Just create simple copy from the part workbench?
No, you could actually, in order to have a, like for example, we did the D3D CNC circuit mill not using the full parts, which each of them is like a meg, so you end up with a 50 meg file. We're just using like a 5K file that's a super simplified, you know, like 1020K.
I saw that, but then I wasn't really able to use it. It wasn't useful to me when I looked at it. It was kind of useful, but not really. But if you look in this folder, I mean, your file sizes are not large. Can you add columns? Size. Yeah, there's size. Here we go. Your file sizes are not that large. The assembly files are large, but the individual files, like this motor pulley assembly, you know, they're
Right.
not that big. Anytime you have a, so like the 2-inch carriage is only, this is the one that has all that complicated geometry. It's only 350 kilobytes.
Yeah.
So,
Yeah.
anyway,
So
so if I just flip, I'm just gonna cancel this real quick, and maybe it's installed. I don't know. No. But what you would do, basically, there's going to be a workbench. There's going to be a toolbar up here, and you can click this. Hide that. You can. You can click any one of these, and then click up on your A2 Plus workbench. It'll say Edit this component. It'll open up this this subassembly, and then within that you can edit those components. And like, this is a subassembly, this is a subassembly, this is a subassembly.
yeah, it's really cool.
And then you can, eventually you'll be left with a single part, and you can modify your part.
Yeah.
Save that, go back in assembly, or an A2 Plus workbench, click update parts, and just save your sub-assemblies
Yeah.
in a linear fashion, and then eventually you'll get back to here, and this will update as well.
That's really good. And if you want to do, and this has got basic detail, if we want absolute full detail for certain purposes, but we still not want to work, well, the full detailed file,
This is full detail.
no it isn't. It doesn't have every single
It's not perforated.
deal on, I mean, it's not full detail. You're always dealing with some form of abstraction. Like if you added a single belt here that's a real belt, this would blow up like a few more meg, right? So, but the idea is that if you want to work really fast, like right now, this is nice and workable, but that's because it's only what, a few meg? But if you keep adding more detail for actual accuracy, at a certain point you will explode. So if you still want to work with complete assemblies, you would simply and I like the workflow in the new assembly workbench, you can substitute a part that's just a lower resolution, less detailed version of that, and then you can still see how everything fits together.
Which workbench is that?
No, in your workbench right now. It's an advanced version of the current workflow we have, where right now we're simply merging, which is a lowbrow way to do what's happening here, which is automated.
But then can you do constraints? Like how do you make?
No, you can't. You can't in there. We're avoiding that.
Position it in space, right?
We're positioning in space.
That's pretty slow.
Well, once again, going to the idea of crowd design, theory being that you can get more people doing that, because right now you have to have the skills of assembly, whereas before you need no skills, you're just moving things around.
Easy. You just click two lines.
It's easy, but but if you talk about, imagine taking people off the street to do this, to teach them really fast. Yes, of course, that's the further lessons, but an initial lesson, you can even do this.
My takeaway from this experience was that people without much experience in CAD, when they do create CAD files, it becomes very difficult to modify downstream. So
That's
what I
right.
end up doing is redrawing them because you don't have basic sketches that you don't have a good starting point, so you don't have a good foundation. So when you work with things like booleans, it's actually a lot more difficult to make changes down the line.
Yeah, but the answer is always and. So say the less skilled people, they would be making their designs that are not in an assembly format, and then a person can take that file, and then you can actually use that in the full assembly. So a lot of people can
they would make individual
collaborate.
parts, but I'm saying in the individual parts, there has to be an emphasis on designing for modifications later.
Yeah, of course the
All of
assembly
these- every
workbenches
single one of
allow
these
that.
files I had to modify later.
Yeah, of course, yeah. So, look at this, that's beautiful. Thank you, Aiden. So, right now, what's the state of the frame? People are working on a frame, and what's the status of that?
John Paul has that frame comment.
We have a almost
Justin?
Three
Three sides done.
almost done.
Yeah. Okay.
So I'm assuming you would only be wearing those. The weld seam doesn't matter.
No, it doesn't seem
And
to
only
matter
kind of
so
on
much.
one side. They beveled it so they've got good penetration. So, I mean, I can have them on the other side.
Yeah, I mean, we don't really have the time. We can touch that up later. So we're okay. We're okay with that. I mean, because at the end of the day, yeah,
At the end of the day tomorrow.
right. So we don't have time to do all of that. So we can do what we can. But right now we're actually welding the sides for all the people. We got 3 sides welded, and then we assemble it all into one piece. And then the limit right now is printers. So probably let's get to that. What else do we need to coordinate?
We need to make these metal plates.
So making metal plates, so we've got metal plastic composites, so each of our 3D printed pieces has that's plastic for the 3D geometry and then metal around that. So metal plates for the making, so do we have a good way to do that?
Yeah, but
Okay.
I mean, the way I would do that is I would start with the nearest size stock that we have.
Yep.
If it needs to get cut, you cut it after you do the center holes. So
Yeah.
So what I would do is I would cut them to length.
Yep.
If the width needs to get modified, we'll do that later. You mark out the hole pattern using a center drill on a mill. So you would do, let's say you have 6 plates to do and they're all the same pattern. You do all 6 plates one hole. Then you move your mill to the next hole. Center drill all of the next hole on all 6 plates.
At a time?
Yeah, so you do
Not at a time, I mean.
so you can take,
do one at a
instead of an
time.
end stop in a mill vise, you can actually take a part out, put it back in, and
Yeah.
make true within 5,000,
Yeah.
more or less. So you can do all 6 of, you do one hole on all 6 plates, just marked with a center drill, not the real drilling operation. And then you have somebody, you take those center drill hole plates, and you have somebody drill them out on a drill press. And that way you can have all of these being made in parallel. The
Yeah.
bottleneck is the person that's center drilling. So, but this gives you.
And okay, what's the center drill do? How do you register that on
Oh, so
a drill press?
the center drill is only on the mill. It's just for marking the center of the hole instead of punching.
So
I mean, you can have people lay these out and punch holes.
Oh, I see, I
Or
see.
you use the DRO as your measurement device. And you just,
So you're making the individual
you just
plate.
Detect a little center hole.
Yeah.
You know a center drill?
Yeah. Okay, so you're doing the actual hole pattern for a
You
plate.
do the whole pattern
Okay.
in the middle, but you do all 6 of them or whatever at once. And then so
Okay.
you just take them out, put it back in, and then move to your next hole. Do all 6 on that hole. Move to the next
Yeah.
hole. Do all
Yeah. I
6.
mean, whatever works best.
You do it in center drill, otherwise the
Yeah.
drill wanders and then you end up crooked.
Yeah.
So we need
Yeah.
to apply the flow.
Okay. Yeah. So we can get to that. So Aiden, do you want to handle that part, and maybe other people work on getting all those printers running? You guys are welding, so there's people there. Essentially, does everybody have something to do for today, or is anyone looking for employment? So you've got to work on the work on the 3D printers. We're going to continue one by one, shaking them down. There could be one person, like if the printers that are finished, to get it running properly. I mean, make sure that everything's stick. I mean, we're really figuring out the production engineering, like what exact temperature is the best. Like how do you make? Like right now we're having issues with sticking. Like not Aiden, William, did we overcome the issue of sticking to the bed? Okay. Well, I know that on the new printers, when we did that sample, it was on pretty hard. I'm not sure what's going on with the older printers. It could be that the bed is insulated and just retains its temperature much better and more stably.
Consistencies in the bed temperature last night when we got temperature probe at it. And the thermometer that was on this was also
So we're thinking that on a regular heated bed, the uninsulated one, you're getting cooler corners. Yeah. Yeah, sure. I mean, it's... Okay, so actually that would explain that, yeah, the new beds can actually work much better because they're insulated, so their thermal properties are going to be much better. So that we may end up not using any of the old printers, and that's why we went to the heated bed, one for energy and one for just better thermal gradients.
So thank you, Scott, for that.
Okay, so one person, I mean, we do have at least one print, like the one printer we did last night, right? That's working,
It's
right?
working until I ran it.
So
What'd you do to it?
I just turned it off. Remember I told you.
But what happened?
It's printing.
Yeah, but I mean, it's working, right?
Yeah.
It's working. So we can have one person at least do that, take the print file and just start and print it, hit print, download Cura, slice it. So that means you put in like settings like it's got a 0.8 millimeter nozzle. You want this kind of a speed. I would recommend actually going at pretty slow speed, like maybe, I don't know, like 30 millimeters per second, even, at least for the first layer, or maybe even 25 for the first layer, and then going to like regular, which is 50 millimeters per second, because we want to make sure the first layer is really good. We might want to do brim, which is a bunch of lines around it, so that the prints are sticking more. Typically, what I do is print just nothing, like nothing underneath, no brim, so that it's fast and it, actually I print vertically typically and it sticks well. But here with these large parts, they're large, they might, if there's temperature differences, they're gonna come off the plate.
And if we're having problems with lifting on the corners, I have heard that new versions of Cura have what we call house steers, which are like little bits of brim around corners specifically.
Use it, download it. That's the production engineering side. Somebody's got to figure it out. We have not printed in 1.2 nozzles, I mentioned. We did 0.8, the greatest, so we're moving to bigger size, which is rewarding. It prints super fast, big nice strands, but we got to figure out exactly how to do that. That's the part of the tricks here. The first time you do it, you need to figure out the details and then save the settings file so that everyone else knows how to do it. And write down comments like, how do you do that? How do you make it really work every time? Because right now they're coming off the bed.
Just for the record, we keep mentioning larger nozzle sizes. You know that means that it's harder to print tiny bits.
Of course,
You're
yeah.
writing with a very smart script.
Yeah, so much more brute force large feature parts, but that's what we have. The parts are bigger than normal. Ganesh, anything? So yeah, if a couple of people want to get on own a printer and make it, develop what's called the production engineering of that part, and put it on the wiki.
I think we should just focus on making one axis.
Okay,
That's realistic, right?
it's realistic. Unless people are staying more than 9 days, one axis is realistic. We would have to have everything absolutely work like right now, and the printer would have to stick right now for us to hope to get any meaningful number of parts.
On printing.
We could do that. So yeah, let's focus on that. But people are making the frame, which is still valuable. I don't think we want to abort that and start drilling the plates.
Doing the frame.
Keep doing the frame, keep doing the plates. Basically, get as many axes as we can. We get one axis that fully works. Wow, that's still impressive because you'll see how big that thing will be. And it'll be the foundation for the next immersion, where we can now take that. We know everything about that, and we take off from there. So the first step is making more axes, not designing or figuring out how to print them or build them. So we build, every time we build upon what we have already until it's like crazy. Yeah, so whoever needs tasks, I mean, settle on a printer, make one work. We got a bunch of them that are like almost working or working. We're going through like the last two to get them to work. We've got some weird electrical stuff happening in a couple, which we're troubleshooting, but that's part of the Murphy's Law here, that everything goes unexpected until we get more and more experience, and then we knock off, we stabilize the versions, we stabilize, okay, this is the package we know absolutely works, and we stick with that, and I kind of force ourselves to do that because we always tend to go further and keep innovating on new stuff. That, yeah. So, any questions? Okay, let's just do it.
Okay, go ahead.
Okay, we'll stop recording here. So